Want to review a fact we did last unit? What did I call angle 1 up there? Exterior angle. What was the fact we learned about it last unit? It's if you want to find that exterior angle, angle 1, you do what? You take angle 2 and add to angle 3. Anybody remember what we called angle 2 and it? Remote interior angles. I am going to take that fact a step further today. If angle 1 can be found by taking 2 and then adding 3 to it, shouldn't angle 1 be greater than angle 2 by itself? Does that make sense? And same thing can be said, angle 1 could also be greater than angle 3 by itself. We're all in agreement there. All right, so that's the first theorem you're going to figure out today, which is already in your notes. What do we call angle 1? Exterior angle is always greater than either two, what do we call these? Remote interiors. And that's what the theorem is right up top there. All right, that any exterior angle of a triangle is greater than the two remote interiors. So in this diagram here, angle DCA, which is an exterior, will be greater than, I'm going to turn it over to you guys now. 2, name an angle it should be greater than. DCA, exterior angle, should be greater than angle A. Got it? There's a remote interior. And angle DCA should also be greater than, name the second angle. Here we go, 16. Angle B. Please do not use this theorem at all to compare the linear pairs. I do not know which angle's bigger. Don't pull the old, that one looks bigger argument. That doesn't fly in here. All right? You cannot tell me which angle is bigger from the linear pairs. All good. All right, I'm going to turn this over to you and your group in a second. State all angles in my diagram that are less than 7. Angle 7. State all the angles that are less than 7. I will give you a little kickstart here. Everyone agree angle 7 is an exterior angle. Name the triangle it's an exterior angle for. MLK is one of them. So it's an exterior angle for this triangle, which means it should be bigger than the two remotes. And it's also an exterior angle for a second triangle in here. The big dog, JKL. All right? And I'm going to challenge you and the people that you sit around. I have found 5 angles that are less than 7. Your turn now. Go right ahead. 5 angles that are less than 7. Remember, we said 7 was exterior, so you want to start identifying remote interior angles. Angle 7 is an exterior, so find all the remote interior angles for it. .30, start us off. Name an angle that's less than 7. Angle 3 is a good start. Angle 3. Why? Because it's a remote interior in triangle JKL, the yellow one I have up here. All good. All right, 1 down, 4 to go. 20, another angle that is less than 7. Angle 4? Yeah, you're right. Angle 4. Now it's a different triangle, though. Now angle 4 is a remote interior for triangle MLK here. Good? All right, 2 down. Nice job. 2 for 2, period 2. What do you have? 23. Going to keep the train rolling. Angle 5. Yep. Angle 5 is a remote interior for triangle KLM, the green one. All right, 2 more we're looking for. 24. Any others? We don't have a 24. Good. Good job. How about 12 then? Nice. No number there. JKL. Everybody see that is the remote interior in triangle JKL, the yellow one. That's a remote interior. All right, so you guys found all the remote interiors for me. You found them all. But there's still another angle out there based off of this answer that I just got that angle 7 has to be bigger than. Okay? And based off of JKL, what else could you go? 9? LMK, isn't that angle 5? Okay, JKL is made up of what two angles? JKL is made up of what two angles? 2N. 2N. It's on your paper too. Hey, JKL. What two angles make up JKL? 2 and 4. Everyone, 2 and 4? I already know 4 there, but is it, if 7 is greater than JKL, shouldn't it be also greater than the other two angles that make it up? So not only is it greater than 4, it's also got to be greater than 2. Everyone see why? If JKL is less than that, and 2 makes up JKL, well, 2's got to be less than it as well. All right, you're not done. Now name 2 angles that are greater than 6. And I said 2, I gave that away. There only are 2 angles that are greater than 6. 2 angles that are greater than 6. 6 is interior now. Find an exterior angle that makes it remote interior. Do not give me angle 7. I do not know that relationship. You can't, don't even tell me it looks like it either. So find an exterior angle where 6 would be considered remote interior. So I'm hoping you're giving me exterior angles here. I'm hoping you guys are giving me exterior angles for these two. All right, here you go. 7, got one angle. Angle 8. Take a look, everyone. Angle 8 is an exterior angle for the big triangle, JKL, where 6 would be remote interior. Anybody find the second one? 17, angle 1. That one was a little bit tougher, but look, angle 1 is, I know it's inside, but it's still an exterior angle for LKM. All right, so yes, it can be, an angle can be interior, but exterior for a separate triangle. And 6 is the remote interior. Questions there before we get to this pretty darn tough multiple choice question. All right. Triangle ABD, yep. AB is congruent to BC, so might as well mark some hash marks. And I'm hoping at this point in the year, you are doing your own set of markings right after what you just did. I'm hoping at this point. If AB is congruent to BC, hope you're right away, just like a magnet, putting another set of markings somewhere. What else can I mark on the diagram right now? After the hash marks. Oh boy. Oh, yep. Do we have a 28? No. We have a nothing. There's my result. 1. Angle A. Ooh, be a little bit more specific than C because I could go a couple. There you go. In a triangle, congruent angles across from congruent sides. Nice. All right. So there are my 4 choices. Which one is true? Woo-hoo. It's going to be hard for me to compare 2 angles in the same triangle. So I'm going to get rid of choice 1, which is 1 congruent to 2. There's no way I can tell if 1 and 2 are, one's greater than the other. And the same thing can be said for 3 and 4. That's going to be hard for me to tell if 3 and 4 are congruent, or one's bigger than the other because they're in the same triangle. So down to 1 bigger than 4 or 4 bigger than 2. Do you guys see any exterior angles for any triangles up here? And remember, when I say exterior, it could also be an interior for another triangle. Does anybody see any exterior angles up here? Because you have 3 different triangles up here. So anybody see an exterior angle that I could use up here? Natalie? Okay. Natalie says, hey, angle BCA is exterior for the triangle on the right, BCD. Everyone see that? We agree on that on your diagram. So, because it's exterior, it's got to be greater than, name an angle, it's got to be greater than 3. You could use 3 or you could use 4. I'm going to use 4 because I know what's coming up. So is everyone all right with that statement? BCA, because it's exterior, is greater than angle 4 because it's a remote interior. Didn't you just mark something minutes ago that was equal to BCA? Angle, just substitute that in, right? These two are equal, so angle 1 also has to be greater than angle 4. All right, everyone okay there? All right, I've been giving away a lot of hints. This next one, I could take all class before somebody finds it. The second theorem we're going to go over today. I want you to try to notice any pattern between the sides and angles. And I guess I'll give you one hint. Yes, there is a third blank angle. You might want to find them so you can tell me what the pattern is. All right, so I'll let you guys talk as long as you need to talk and see if you can come up with a pattern between the sides and the angles. All right, a lot of good discussion. Productive discussion, good. All right, let's see this relationship here. Hold on, before we start. I can guarantee when you give me this angle that it's going to be less than 56. What was the missing angle? I guarantee it's less than 56. 42, look at that. And I'm using this fact that hopefully you guys came up with to say that. This next one, I'm going to say the third angle is less than 40. What is it? All right. How'd we come up with that? How did I know it? Sure, Cece, go ahead. What do you got for me?
You just add the 2 known angles and subtract that. Wait, what do you?
Yeah, that's how I got the missing angle. Thank you. What's the relationship between the sides and angles? What's the pattern here?
The smallest angle is across from the shortest side. And the largest
Yep.
angle is
What's the largest angle up here? Okay, well, the 80 in this triangle, it's 82. What's the largest side? 7. They're across from each other. Smallest angle, 42. What's the smallest side? 4. They're always across from each other. Always, always, always. There's no exception to this. First theorem, in a triangle, largest side is across from. Where's the largest side across from? Largest angle. So your second theorem here today, along with the exterior angle one. I don't know why I put 2 theorems in, because I'm going to say the same thing, but for the smallest. You could also flip angle inside if you wanted to. In a triangle, smallest angle is located where? Yep. Indeed. Nope. Okay, everyone. So you had the exterior angles bigger than the remote interiors, and now you had in a triangle, biggest side across from biggest angle. All right, let's apply it, and we'll get out of here. These 2 triangles coming up. Shortest to longest side. Shortest to longest. So I need you to list out the sides for me from shortest to longest. You can go right ahead. I don't think I need to do this one with you. And if you were wondering, Cece, how do I find the missing angle again? Never mind. Don't worry about it. In case people were wondering. Hey, gonna need some rankers here. Number 1, rank them from shortest. 10, shortest. BC, followed by BA, longest side. CA, nice job. Any issues there? Need a ranker for number 2. Oh, 12, perfect for the job. Here we go, smallest. Next. And the biggest side. There we go. Any issues there? Going to need some algebra studs to step forward on the next one. Okay, we got triangle ABC. We know a little something about the angles. Angle A is 3x. Angle B, 4x minus 19. And angle C, 3x minus 1. And this is a multiple choice question. It's asking me, hey, is it isosceles? I don't know. Is AB or AC the longest side? Heck, is it obtuse? I cannot answer any of those unless I know something about their angle measures. So out of the 3 that you have up there, you want to do something with those 3 angle measurements so I can actually find how many degrees are in each of them. 1. What can I do with all 3 there? Yep, that's why I need the algebra studs to come forward here. I'm going to add up all 3 angles, set it equal to 180 degrees, and solve for x, which somebody will in a second. Give you guys a minute to do your thing. If you're not done yet, take your time. No rush. Find the value of x. 7 when you're ready. 20, yep. All right, let's go back. Plug it in now. Go back to your triangle. Plug in x equals 20 so you can tell me the degree measures. All right, little help here. 14, little help. Did you find angle A?
Yeah.
60. How about angle B?
61.
61. And then finally angle C? 59. 9 degrees. Nice job. All right, is it isosceles? No, it would be if two angles would be congruent, so it's not isosceles. Is it obtuse? Nope, one angle's not bigger than 90. So now we're down to what's the largest side? Well, what's the largest angle? Angle B, 61 degrees, and what's across from it? AC. So there you go. AC's got to be the longest side. All right, that's great. Let's raise it up to the honors level now. And to raise it even more, please cross out longest side. I'm looking for the smallest side here. Longest side's too easy for you guys. I'm looking for the smallest side. And I'm talking in the entire diagram, not each triangle, the entire diagram. What is the smallest side? And a lot of you guys are punching buttons, which is good to see because you probably want to find the two missing angles before I start any discussion with you. Good idea. All right, you guys are finding the angles. What's angle ADB? 60 degrees. CBD? 57. So I wouldn't blame you. Based on what we did today, you're going to say 53, smallest angle. What's across from it? BD, smallest side, we're done. That's a big issue, though. Here's why I can't say that. Because take a look. All right, BD may be the smallest side in this triangle, but it's not in this one. So how can it be the smallest one in the entire diagram? All right, so here's how we're going to take care of these problems because I want you guys to visually see what I am talking about right now. How many triangles are in the diagram? 2. You are going to list out from shortest to longest the sides in each of those triangles so we can compare them. And then what I'm telling you hopefully will become a little easier to see. All right, so one person right now, can you give me smallest to longest in triangle ABD only? 9, let's roll. AD, followed by BA, followed by? Oh, okay, got it, thank you. All good. Could somebody please rank the sides from smallest to longest? In triangle BCD? Yeah, 21, come on. Correct. BD. DC. And? Okay. So we got a matchup right now because I'm trying to find the smallest side. The matchup is between AD and BD for the smallest side in the entire diagram. Can't be anything else because they're all bigger. All right? But there's one of these I can get rid of, though. Out of those two, I can eliminate one. Which one can I eliminate? Okay, why BD, though? Ready? Because you've already, look it over here. You've listed BD as the biggest one. There's 2 more that are smaller than BD. So how can BD be the smallest one in the entire diagram? So it's got to be side AD. Love these type of questions in an honors level class right there. Okay, just don't look for the smallest angle. All right, but it becomes, I think, very easy when you start ranking them. Questions? What if I say, oh, we're in what class here? Yeah, what if I said the next smallest side? Would you choose BD then? No, what's the next smallest side after AD? BA, because BD is still bigger than it. That's why we ranked it that way. All good. So if I had you, because I will ask you to do this, rank all the sides from smallest to longest. You said AD, which is my final answer here. What's next? BA. Then I could finally say, what's after BA? BD. Now I'm down to these two. DC, this is why we rank them. And then what is the actual largest side here? B, C. Yeah, comment down. DC, then BC. Okay, because I will have you rank them from shortest to longest in this type of problem. Okay? Questions there? You all right? Got what?
What do they come down to, like, the angles, though? Like, if it's not, like, BA and BC?
But you've ranked these right now, right? So once I get past BD, all of these were used. So now it's coming down to these two. So it does come down to the angles. That's why we ranked them this way.
Wouldn't DC be shorter than BA then?
Then what?
DC be shorter than BA?
But BD's bigger. And BD was the smallest side here, so, okay?